Hello, welcome everyone back to Fun with WebGL 2.0. Today's a special day because today it's a Sunday morning and I'm recording during the day instead of midnight. So I should be a little bit more awake and a little bit more giddy about what we're doing. So we're going to continue off what we did in the previous lesson where we kind of started up our own frame buffer. And what we did is we used our custom frame buffer to set up a color per object. So this way we can then use that information to know which object we are clicking on by using that data to know, what pixel did you click on, and based on that pixel we derive the ID number of the object. Now in today's lessons we're going to take frame buffers to the next step. Now we're going to use a new feature that's related to WebGL 2.0, which is multi-render targets. Now, multi-render targets it's where we can set up multiple color buffers in our frame, and we can draw to both at the same time, or all of them at the same time. In the previous lesson, we did a custom buffer, and we had our display buffer, the standard, the default, and we kept going back and forth, setting the frame buffer that we're currently drawing to. So we draw our picking, then we switch back to draw our display, and we back and forth during every frame. So in this situation, we don't need to do that anymore. We can set the frame buffer to be our custom, but then we have to do a second pass where we have to take all that information and then draw it again, but as one large texture. The idea is that we're going to create a buffer, a frame, that consists of two colors and one depth. So the first color buffer is going to be a texture that we're going to that every texture or every fragment shader draws to. And here's the beautiful trick of it. In the previously we used the zero attachment for the color zero attachment to draw our picking. Now we're going to do that. We're going to use the color attachment 1. Because when I was playing around with it, I kind of realized if I don't have a shader set up to do our MRT, multi-rendering targets, it automatically just draws to the zero color attachment. So the grid shader that draws the grid out automatically draws to that first texture. So then when we start drawing the cube will draw the two textures. We'll draw to 0 and we'll draw the color attachment 1. So it's kind of a neat trick. If we set it up that way, we can use everything we had in the previous lessons and everything will kind of render, and the only extra, it won't be an extra step at all. But the thing is, we render everything. So here's the kind of the workflow. We're going to render everything into our custom frame buffer. And then when all that is done, we can then do one more render to a quad that fills up the entire screen, has no projection, no model matrix, no nothing. It's just a full screen quad. And we take the text attachment 0 and we draw that onto our quad. So basically, we're basically drawing everything, and then at the very end drawing it actually on the display on the canvas. This is actually done for something I think called deferred lighting, where you draw all your objects and all your scenes on a custom frame buffer on 5 different color attachments, and then at the very end you kind of piece it all together. The idea is that regular lighting, we kind of spend a lot of time colorizing every pixel. And then you might have another object that kind of overlaps it. So you're kind of wasting all that mathematical time calculating lighting on pixels that are going to be overridden by other objects. So the notion is, with a deferred lighting, we're using all these frame buffers, is that you draw everything, you save your vectors, your normals, a bunch of information on each color texture. And then at the very end, you only have to apply lighting to one pixel at a time, and that's it. You're done. So you save a lot of time CPU-wise doing that. And here, there's also another beautiful thing where you actually render your entire scene to a texture, and then at the very end do something. You can do something called post effects. That's when you can start blurring the screen or do other things. Like you can apply some kind of effect or some kind of filter, like if you're from a Photoshop, on the entire scene. So we're going to do that too. So first thing we're going to do, we're going to go into our fungi and we're going to change our quad. Originally it has just a function called quad that created our quad. I renamed it to quad 1U. That's like 1 unit. So everything here is 0.5. So our quad is actually just 1 unit big. But I need a quad that can fill up the entire screen, which needs to be all set to ones. So I'm calling this quad 2. 2 units. It's 2 units because you got to remember it's 1 unit to the left of the center and 1 unit to the right of the center. So it's the quad is actually 2 units big in all directions. So that's the only big change. It's renaming it, and I changed it. And since I'm using this to draw our final canvas, we don't need index. I just try to cut it down, make it less data. I think there's a slightly less data than this one, just by a smidgen. By a couple of bytes or something. I forget. I know I tried to kind of do the math in my head, but I don't remember anymore. That was a couple of days ago. So that's our primitive. Now we're going to go into core, and we're going to kind of do a couple of changes. One of the changes we're going to do is to shader builder, and we're going to change set uniforms, because we can use our frame buffer textures as textures to render. So, and at the end when we do our final rendering, we're going to take our color buffers and use them as textures for drawing. So, since the new fungi stuff, I really haven't done any texture stuff. I thought, let's just fix up set uniform, and that will do a good job. Like previously, we had prepared textures, and I'm probably not going to use that anymore. I'm going to get rid of it. And just treat textures as uniforms. Don't do anything extra. Don't do anything special about it. So one thing we're going to do is keep track of the current text count, because you have to apply it by numbers. So when you set uniform, you have to sort it. You have to set it in the proper order that they kind of exist, or the exact order basically that exists in the shader. So so that keeps our count, and we check its type, and if we say the type is text, we set the active texture, and we're just grabbing the constant value. So I'm just taking texture and then whatever number we're currently on, 0, and that's the constant we're setting. It's the constant names. I'm just using it this way. So this one I have to do a bunch of if statements. So that, if 0, use texture 0, or like GL that texture 0. If it's 1, use GL. This way is just a quick way of just getting to it without putting a bunch of if statements or structs. Then we bind a texture, and then we push in the texture ID from the frame buffer. And then we just uniform ID. We set the location to use which texture is currently active, which is 0. So we activate the texture, we put the texture in that activated texture space, and then we tell it that this uniform points to that, and then we increment. So if we add another texture, it will then use number 1 and number 2 and number 3. So try to make this very slim, very easy. I think that was the only change I had to do to shader builder. So this way we can do that. Now a lot of the I did quite a bit of changes to FBO because we want to use FBOs in a different way. And I thought of a nicer way to kind of build it. Like previously, we had color depth FBO, and this will kind of build the texture, the custom frame buffer that we're using in the previous lesson. I added this little change because I fixed that function. I was thinking we don't need that anymore. because that's too specific. Maybe we don't need something specific. Maybe I made something more generic. So build is our generic function. So we kind of pass in our name. We pass in how many color buffers we want to use. We tell it, do we use the depth? Because you're only going to have one depth buffer anyway. At some point, I might add like use stencil, and they'll just apply that one stencil. And then we give it the width and height. If the width and height is null, we just use the text, the GL canvas's size. So that's automatic, or you can set the size specifically if you're going to use an FBO to do some kind of fancy rendering. We create a FBO. If we're using depth, we create the depth. We pass in our width and height, and then based on the account, we just use we just keep creating texture buffers until we're done. And the constants are incremental. So if you say you want do 0, like you pass in the count color count of 0, that means it's going to do just a single yeah. So actually you have to pass in 1. I'm sorry. You pass in 1, but it starts from 0. So if you say you just want one color attachment, it will just say 0 plus that, and that's fine. If we have 2, so when you go to so it'll be that plus 1, we just increment the ID number. So again, it's another quick way of just accessing it. Since and we can only have up to 15 now. Now I looked it up since the previous lesson. I wasn't sure. We can have it's 16, including the 0. So we can have up to 16 color buffers in our custom frame buffer. So if you put in here like 17, you're gonna get a big error. So 16 is the maximum. Probably put an if statement in there that checks, but I'm not going to make that mistake. And if I do, the game will crash, and I was like, oh, I made a mistake. So that's it. What is this? GL.draw buffers. We have to set how many draw buffers we can draw in. If you're doing multi-targeted rendering, we need to set this. So for drawing more than one color buffer, we need to set how many draw buffers are we allowed to draw in. So that's what this does. It's like, oh, okay, so we're drawing more than one, set up the actual count. And what you have to do is you kind of have to save this. That's kind of like the other thing. So we have to save the color attachment in an array, and then we pass in the array to draw buffers. It's been a couple of days since I've done this. I'm trying to remember how you do this. So yeah, we have to do that, and we finalize, and that's pretty much all to it. So this is going to be our generic builder function, which we'll be able to build any FBOs that we want in one quick go. Our color buffers are now an array because we can do more than one. With color attachment number, we now just use the actual number instead of actually passing in the GL constant. And we have to pass in the width and height now. And that's the only real difference. We use the number, we create the texture. That's another change because we were using an array. We used that array. Our width and height is right here. And everything's pretty much the same. And then here's our constant plus the number. And we added the array here because we're using that. So that's the big changes for it. There was a lot of changes to this one because like we were making it an array, and then we got to apply it in that kind of fashion. Depth buffer. The only change we did was width and height because we need to define it. That was it for this one. And another big change is read pixel. And since we're doing multi stuff, we kind of have to use the read _ frame buffer when we want to read a pixel. I think we still can just do that with just frame buffer, but this exists in WebGL 2.0. You should kind of use that for reading. So this way you can keep the GL frame buffer still applied, globally, and then you can use this place to do reading. So this way you're not going back and forth between frame buffer so much. They also have a write underscore frame buffer. So we set up our read, and then we tell it which attachment. That's another big change. Now we have to tell it which color attachment are we reading from, and then everything is the same, and then we unbind it. So that's really the big changes here. Is we're switching the place of the location of where we're reading it, and then we're telling it which color attachment to use. And that's it. Everything else pretty much stays the same. And that's the change of the fungi core. Now if we go to test, we're going to have a couple of changes. We don't need blank anymore. We're not going to alternate back and forth anymore. So we're all drawing everything in one go. So, and we don't need on item render anymore either. And here's our original color FBO picking. Now it gets replaced with this line. You know, we'd give it the name. We say we want 2 colors and we want depth. And I didn't set the width and height. It's going to automatically set it based on the canvas. So that's nice and quick. It's very generic. We can build this by just changing that to 1. Let's see. Another change we have to do is here. We just have to tell it which color buffer we're reading from. That's only a small change here in our controller set down override. I think this is pretty much the same. This hasn't changed because we're still setting the color when we're drawing our square, our cube. Now we're going to use a second shader, and I'm calling it the final shader because it's the final drawing. It's the second pass, or I guess what they call it sometimes. And we're setting up, we're preparing texture 0 and texture 1, and their type of texture. And you got to create create the shaders, then we create our materials, and I'm creating a material for the final shader, and I'm setting use model matrix to false because this one is not going to use model matrix. So we got our G model, we got our face cube, we got our grid floor. So we're going to draw these 2 objects, the floor and our cube. And then we're setting up our final quad, which gets the final rendering, and it's our quad 2U, and here's the material for drawing it. And that stays the same. And for this lesson, we can't use fungi.render because we need to do some special things. So this is a case where we kind of need to build a new renderer function. So at some point, when I think of a more generic way, I might end up rewriting renderer to be a class so we can make it more generic, so we can extend it and then have the unrender part change. But for now, we're going to put it onto this page. So here's our new render object. It's bare bones. I kind of cut down. I pretty much took our render from fungi, brought it here, took out everything we don't need. So it's still doing our checks between materials and shaders. It does it bare bones. And now I'm drawing the object. I'm just doing the shortcut. Since we created this function in the last lesson, I'm just going to use it, just render it. So right here, we're setting up our custom buffer, our multi-targeted render buffer. We could draw everything in our list, and then we're going to switch over to the main buffer, the main draw buffer. We're going to bind our VAO for our quad, our final quad. I'm just doing the materials and the shader checks because when we come back to the next frame, I want these to be different, so these will trigger. Like at least this statement will trigger. So this will draw things over again. So I just want to make sure that's correct. and we're activating our shader, and then we are going to set our uniform text 01 to our color buffer 0. And then we're just going to draw our final quad. So now we're going to go check out the shaders. I pulled all the picking stuff out of here. There's no more of that beginning if statement that or the uniform to kind of swap in back and forth the constant. I moved some of that stuff to the fragment shader. There's no more constant anymore. And but the uniform for the color ID is here. Now it lives in the fragment shader instead of the vertex shader. And here's something new. This is how we target our color buffers. So we have 2 outs now. Now we can do 2 outs. So the 0. Remember, like I said, this is when we draw our regular stuff, and this is where in out number 1, the second attachment, is where we're going to do all our picking drawing. This way we can just draw that. And that's really how simple it is just to apply it in our shaders. If we have like 5, we just keep incrementing and just keep adding additional out variables. And our final is going to be very bare bones, very simple. UV is important because we're drawing a quad. And there's a lot of stuff in here, but because a lot of us commented, we're going to go through some of the effects stuff. So, but for our final draw, all we really need is the texture that we're sampling. We're not really using this, but I put it in there anyway, in case I want to do something with the second texture. So we just grab the pixel, and we just draw the pixel, and that's it. We can ignore everything else for now. And let's see, I just want to go back to something. Okay. And there it is. And nothing's changed. Now we're rendering to our custom buffer, and picking still works. Everything still beautifully works. Now the only thing maybe you won't notice is that the edges are more jagged, because now we're drawing from a texture instead of just rendering exactly. So you might notice that certain things are a little bit more jagged. So I think that's when anti-alias comes into play. So you can kind of smooth out the lines, which ends up becoming, I think, a post effect that you have to apply. So right now everything's kind of jagged because we're drawing like from a texture. Now remember, when we set the uniform to text 1, we're using the first buffer. Now if we want, we can set the second color buffer. And if we refresh, this is what the color buffer of the second attachment actually looks like. And as you can see, you can kind of see the grid going through, which is correct because the grid exists, kind of overlays at this angle. It does overlay it. So ideally, when I click that exact pixel, I shouldn't be able to move the square. It's kind of hard because it's very small pixels. So I'm still rotating it. So that's good. It works. Because ideally, if we're going to do like a color picker for the grid, that means this is how I can kind of pick that grid. Whoa. So, but there you go. This is what our color attachment looks like on for picking. So if I go back to 0, that's good. Now that's really all it is to do multi-targeted rendering. It's pretty good. The frame rate is actually pretty good. It gives a good 50, I think. Let me see. Can I uncomment it? Since we're doing a lot of our drawing, and since we're not swapping back and forth, it's going 30. That's our frame rate. Not bad, I guess. I think normally it can go higher. I don't know if it's this computer or maybe because I'm recording. I don't know. But everything seems pretty smooth to me. I don't know. But yeah, it's going 30 frames a second. That's pretty good. That's decent, I guess, for web stuff. So let's try out some post effects. So I'm going to comment that out, and we're going to do color inverting. So we're going to just invert the color. Since we have our color texture, we then can do things with it. So I'm going to just invert the color. I'm going to save it, and boom, the entire scene gets inverted. Like, remember, we're drawing the zero attachment, which is the entire scene drawn as a texture. So when we're redrawing that texture onto the canvas, we can do whatever we want with it. So we can change the entire scene in one draw call. And the frame rate's still doing pretty good. Still 30 frames per second. We're rendering, everything. All right. So let's get rid of inverse. What else we got? We got grayscale. We can apply grayscale. Refresh. No big deal. It's different because most of the cube was gray to begin with. But as you see, the colors now got turned into gray. So you can automatically make the entire scene gray if you want. You can do a lot of things. You can maybe dumb it down a little bit, make it hazy. I don't know. You can do whatever you want. There's also things called kernel effects. Kernel effects allows you to do a bunch of things. So let's see. Comment all this out. This is just one example of kernel effects. Let me just show blur first. So this should work just fine. I'm going to show you like an article of where you can read about it. It kind of explains some of the math and how it's done. It's just what you're kind of doing is sampling the pixels around you. Since we're doing this kind of like double rendering, we have now all the data of the entire scene. Like, it's very difficult to do blur on a single object because you need to check the colors around you, and you can't do that when you're just rendering like a cube or something. But if you're rendering a texture, you then can check the neighboring pixels of the current pixel you're drawing. And that's what you're kind of doing. You're just sampling all the pixels around you. That's why everything is kind of like kind of a matrix of 9. So you got to think of a square that's divided up into 3, and the pixel you're drawing is right in the center, and then you have the remaining 8 pixels around you, and you're just sampling those to apply. So like idea like for I think blur is that you check all the colors around you, and then you kind of average it out, and that becomes the pixel you draw. And that's if I can be corrected, but I think that's the idea of how blur works. You kind of just average it. So if I refresh using the kernel, there you go. We have the entire scene blurred up. We're blurred out a little bit. Let's see. We also have sharpening. Get rid of these. See the kernel of like a kind of like a matrix of some kind. And we refresh, and now you can see everything's gonna get sharpening, and it's kind of cool. It's got that kind of like edge thing going, which is kind of neat. So post effects is a way to kind of just and everything still works. You got to remember, post effects is just final drawings that we're doing. It does not affect our attachment 1 that holds the data for the whatchamacallit for the picking. So that's effects. So I think that's pretty much all the effects I really just copied over here just to try out. So there's a couple of places we can go. There's learnopengl.com. This is where I got some of the effects. Like, it shows you how to do edge detection. That this is basically the kernel to do edge detection. I think this is where this is with example for blurring, how blurring works. It's basically that matrix divided by 16. Grayscale, and the inverting. Then we also have open.gl. They also have some cool ones, and they do the effects. This one does the effects differently too. Like blurring is a lot simpler. Then it doesn't use, I guess, the kernel. I think it does it the same way, but it just does it differently. So when you're looking for information, just search for like Post Effects OpenGL or kernel effects OpenGL, and you'll probably find tons of equations and shader examples of how to do certain things. Like this one looks pretty neat, like Sobel. I'm probably pronouncing it wrong. That's a pretty neat effect, and it kind of just shows you, all the code to really just kind of do that, like how to what textures, which pixels to grab, and everything else. So I'll put these links in the description. So, and you can read more about frame buffers in general. I think there's this one thing this talks about frame buffers. Yeah, it talks about frame buffers, but I don't know if it talks about multi. It might talk about multi-targeting. I just like the fact that it shows you how to do these effects, which is kind of neat. So that's it for today's lesson. So hopefully you learned a lot about frame buffers and how to properly use it. I'm sure if you search for OpenGL, what's it called? Deferred lighting. Probably spelling it wrong. Deferred shading. Sorry, deferred shading. I think that might be the article. This one will show you examples of how to do it, and it's all based on multi-targeted frames. Like these are to perform this side of lighting. Looks like you need to set up 4 color textures, and I guess that's what they call the G buffer. And and it's just like different things. Like that's the normal. That's I can't see the text. It's really tiny. But yeah, maybe I'll save this link too. Yeah, there's a better picture of a normal position, albedo, specular, deferred lighting or deferred shading. So this is another thing you can do, and you can end up producing really cool effects. And it just kind of just renders everything out at the very end. It's pretty neat. Some scary math. So yeah, it's really neat. So yes, multi-target is a great thing. It's something that you do at the very end. There's some cool effects, like I know in the games you kind of have like water droplets applying on the screen, like it's raining. That's something you can do as a post effect. You just apply it. I guess just another texture that applies over the drawn texture. So yeah, I'll save this link as well. And put it into the description. Advanced lighting. So this way you guys can play with it, because now that everything is set up, now it's kind of just really just writing the shaders. At this point, that's all you're doing is writing shaders to use that data to create all these crazy effects and lighting things. At that point is beyond my scope at the moment. So that's all. I don't know how long this will take. Maybe 30 minutes, maybe? I don't know. But it's early in the morning. Hopefully the lessons are better. I'm not so tired. I'm trying to think. Other things I probably want to just quickly mention. I'm starting to learn Golang. It's that language that Google made. It's kind of like their C replacement. I'm starting to learn it. I have the idea of rewriting or not porting fungi to the Golang. There is some packages and there's a tutorial of how to set up OpenGL with Golang, and then using something else thing called GL something to create a window. I'm kind of hoping the idea is that using Golang and some other things, because it's usually a cross-platform thing, so I can probably write it once and compile it, and it should compile for Windows, Macs, and Linux machines. So it'd be kind of great to have a Go game engine that you can compile to all of them. I looked around. There's really not a lot of open source game engines in Go. There's 1 or 2 I found, and one that I found that does 3D, because I think there's 2 or 3, and most of them are targeted toward 2D. where Fungi is definitely going to be a 3D game engine. There's not going to be a lot of focus on 2D at all. The one that does do 3D, it only uses OpenGL 2.1, and that's not going to flow. So I'm going to use OpenGL 4.1. That's available for use with Go. So I was just going to do that for myself because I want a game engine and I want it to be like something, so I can actually make a real game that I can compile and run really well, because web is great and all, but it'll, for a real game, I probably want something on a desktop. So you don't need a browser, you don't need the internet. And Golang has a lot of cool things. It's really easy to build a server in Golang. I've just finished a tutorial on how to kind of put together a simple web server. So like if I want to do multiplayer games, it'd probably be a lot easier because I can build my own little server in Go and then have that included with the game. So this way you can do LAN games or something. That might be fun. Now the only thing is like, I'm really just mentioning it, is I don't know if anyone's interested in me making tutorials on me building Fungi. I don't know if people would prefer just me, if they want just videos of me doing the progression. It's like, okay, here's some things I put together. We can do triangles now, or now we can kind of rotate. Basically all the lessons we've done. Just do an update of what it is if people are just interested in Fungi Go, or do you guys want basically me doing WebGL type of things where I'm actually going to build pieces at a time, and then I'll go through the code with everyone and show you how it works and explain all the lines of code that I modified or that I wrote and why I did it. So this way you guys can learn how to build the game engine in Go as I'm learning to build it in Go. So yeah, tell me what you're interested in, or you just don't give a damn, and I'll just do it in a black box in the corner, and every once in a while I'll post a video saying, hey, look at me, I got a Fungi Go is slowly developing into somewhat of a game engine. So yeah, just tell me what you're interested in. If you guys want to learn Go and get deeper into this and just not be a web developer and be an actual desktop game developer, I'll do both. The idea is that I'm probably going to do a lot of prototyping with WebGL, and then pour a lot of those things over to Go, because it'd be a lot easier for me to program in JavaScript. Just figure out the framework and get the idea of what works and what doesn't work, and then just start porting over the changes to the Go version, which will be like a desktop version of it. So like in the end, Fungi will have two versions. There'll be a web version of the engine, and there will be a desktop version of the engine. So that's about it. I just can't wait to start making games. It takes forever to get to that point building the engine. That's why Unity and Unreal is so popular. And I kind of just, sometimes I feel like I should just go back to Unity and try and start learning how to make games again. But at the same time, it's like, seems like the best route for me in general to build games. But it's a long road. It's a very long road to get there, and I'm anxious. I'm very anxious to get there. I'm just in a hurry, but it's a very long road. It's a long process to learn to build a game engine, to build games. So anyone who's sticking through with this, I give you a lot of props for sticking on with this, because it's so much easier. If you should want to make games, there's better routes than doing this. This is difficult. This is tough. So if you're sticking with it, good job. And hopefully at some point we'll get to the point where we're actually making some fun games, something simple. This is probably starting to take a little bit too long, too much talking, and yeah. So thanks for watching, and like, subscribe, stuff like that, and tell me what you think, what you want to happen in relation to WebGL and possibly my future development in Fungi Go. And see you guys at the next lesson.